So we've got this puzzle. Why should a force, gravity, have something to do with acceleration? Now acceleration is about change in speed, change in motion. So clearly this is going to have something to do with the nature of space and time. And this is difficult because we have a really strong common sense view of what space and time actually are. And it's very hard for us to get rid of our common sense point of view and to think of it as just an arbitrary mathematical construct. So to help us do this, let's play a little game here. Let's imagine, Brian, that I'm actually not a human, but I'm an artificial intelligence. I'm a computer in a box. I have no eyes, no ears, and you're just typing messages to me. And I want to know what this strange thing called space is that you humans keep talking about. How would you explain what space is to me as an artificial intelligence?
Okay, well, that's going to be a challenge. So I think we think of space as being a place that things happen. I think that's sort of our...
But what is a place? What is a place?
A place. What is a place? A place has size and distance from us.
And what is the size and distance you are talking about?
So size and distance. So I measure size and distance by how far light travels in a certain moment of time.
What is this far you're talking about? The whole trouble is that it's very circular. We tend to use spaces where things are in different places, but what is a place? It's all very circular reasoning. I mean, can we think of any way that we could explain it that doesn't involve a sort of circular reason in terms of other words that also imply that we know what space is? It's a hard one.
Well, I think you end up having to just write down a few axioms, as we do in mathematics, and then we can use the language of mathematics, maybe, to describe what space is.
Well, let's imagine, another thought experiment, that space doesn't actually exist. We don't actually exist. We're just a simulation in God's supercomputer, down in God's basement somewhere, a bit like the movie The Matrix. So let's imagine that God has a very big supercomputer, and it has one memory register for every atom in the universe.
Okay. That's a lot of memory registers.
Yes, God makes pretty good computers.
Okay, good.
And each memory register records particle and three numbers, x, y, and z, the coordinates in three-dimensional space. So, for example, the first particle in the register, there's no actual particle, it's just a set of numbers.
Yep.
Might be this atom on the tip of my nose over here. And that's got coordinates, let's define that as 0, 0, 0.
Yep.
And you go down, the next atom in the register might be, let's say, a neutron that's in a neutron star in Alpha Centauri or other end of the universe somewhere. And then the third particle might be even further away, and the fourth one might be one of the ones in your hair.
Yep. So we're going to put them in different memory registers, and so presumably when I get to the one that's right next to that first one, 0, 0, 0, and I'm going to put the atom right next to it, it's going to have a number pretty close to 0, 0, 0. It'll be like 27, 32, 45.
Yes. So what it means is, let's say my nose exploded for some reason. This is a radioactive element and it decayed.
Yep.
Which other atoms will be affected? One which has a coordinate of 4 million probably won't be affected, but one with a coordinate of 0.01 might. So what you could imagine is you have all these different memory registers, and then we do a time step. And we see, well, that one exploded, and then we go all the way through the register and see, it might take God months to do this, and find out every other one which has similar coordinates. So there have to be some measure. If you've got two sets of numbers, let's say 111 and 113, are they close or are they far apart? There has to be some way of comparing these two sets of numbers to work out proximity, and therefore see if an event that hits one of them hits another one.
So you could literally calculate the distance between those three registers.
Yes, so what you need is three numbers, it defines the three dimensions, and you need some way, given two sets of three numbers, to work out whether they're close or far apart, some measure of how much things affect each other.
Okay, so that sounds like a way of mathematically essentially describing space, the set of numbers, and we can think of it as in memory. I could imagine how that might work. And of course we had that concept of time as well we're going to have to eventually deal with as well.
Yes. So, I mean, it could be that is our universe. It actually is no space. It is just a register in a computer. How could we even tell? I think I see you, but that's because photons in one coordinate have photons in another coordinate and then interact with a memory register. The neurons in my brain fire in some sequence. But they could be in quite different parts of this supercomputer. They just have similar numbers.
Okay, so you're saying we could be inside the matrix.
Indeed.
Okay, well, good enough for me. It's got me fooled.